Good afternoon, my name is Elias Haro Jr., and in today's presentation I'll be going over a brief history of programming languages and their applications. I found programming languages and their development interesting because of their importance to software engineering, and I also found it interesting to see their progression as hardware technology improved. Programming languages actually predate the invention of electrical computing devices. In 1843, an accomplished mathematician named Ada Lovelace wrote the world's first computer program for a proposed mechanical computing device known as the analytical engine. The analytical engine was proposed and partially built by engineer Charles Babbage. It would have been the first computing device to incorporate an ALU, control flow, and integrated memory. It was about 100 years ahead of its time, and due to shortcomings in machining technologies, it was never able to be completed. And although it was never completed, Lovelace still wrote a computer program that would calculate Bernoulli numbers using the analytical engine's proposed capabilities. Her program was published by an Italian science publication and is considered by many to be the first programming language. The first programming languages designed for electrical computing devices are known as first-generation languages or machine languages. These are the earliest of programming languages. They are composed of binary sequences that represent CPU actions. Programmers would write programs in binary, which were directly fed into the CPU. An advantage of this was fast execution speed because of the lack of intermediary, such as a compiler or an interpreter. The downside to these languages were that they were tedious to program in and prone to error. Debugging a first-generation program was nearly impossible, and any complex program could not be written using a first-generation language, as even simple programs required a lot of code. First-generation languages had no abstraction, which meant that each first-generation instruction represented a CPU action. This meant that first-generation languages were machine dependent, which meant programs could not be transferred between CPU types, and this offered no portability and almost no chance for standardization. Although no programmers really work with first-generation languages anymore due to the use of compilers, interpreters, and assemblers, they are still used to communicate with the CPU. All languages must be translated into machine code before they can be processed by the CPU. And this type of first-generation languages are used to program low-level functions, as I stated before. The use of compilers and interpreters have pretty much outdated programming in first-generation languages. Second-generation languages are also known as assembly languages, were an improvement on first-generation languages. This improvement came in the use of mnemonics, or words, to represent CPU instructions, memory addresses, and data items. Programming in second-generation languages was easier, and debugging was made a lot easier. But programming in second-generation languages was still complex due to the one-to-one ratio between program instruction and CPU action. Due to second-generation languages using strings and characters that were not recognized by hardware, an assembler is needed to translate second-generation languages into machine code. Although not many programmers code in second-generation languages, they still have their fair number of applications. Most CPUs contain a companion assembly language. There are many types of companion assembly languages, which include CISC, Complex Instruction Set Computer, RISC, Reduced Instruction Set Computer, DSP, which is Digital Signal Processor, and VLIW, which is Very Long Instruction Word. All high-level languages must be translated into assembly language, which is then translated into machine code. And here is an example of an assembly program. As you can see, every CPU action is called out by an assembly instruction. This is a very small program. Larger programs would have many more lines of code. As you can see, the one-to-one ratio between program instruction and CPU action make it very difficult to program in assembly language. That's why compilers translate high-level languages into assembly language, and that's an automated tool that programmers use in modern software engineering. So third-generation languages are known as high-level programming languages. High-level meaning that they are closer to human language than they are to computer language. Third-generation languages are the first languages where the ratio between program instruction and CPU action is greater than 1-to-1. This is also referred to as an instruction explosion. Instruction explosion vary with the programming language, but they are typically have a 50-to-1 ratio. Third-generation languages are the languages we are most familiar with. The first third-generation language is Fortran, which I learned when I was part of the aerospace engineering program at Iowa State. It's a very difficult program to write code in. It doesn't have a lot of the features of more current third-generation languages, but it was used a lot in the engineering community. Most modern general-purpose languages are considered third-generation languages, and these were the first languages which introduced specialization or specialized languages. As I stated before, third-generation languages are the first to introduce specialized languages. Third-generation languages or high-level languages have many more, are much more easier to program in. They're easier to read, write, and maintain by programmers. Um, they are translated into machine language by a compiler or directly via an interpreter. Three-generation languages are also machine independent, which means that code written for one computer can be transferred to another one and it'll be recognized. It's the first language that was designed for structured programming. And as I stated before, it gave rise to specialized languages for applications such as mathematics, which I used MATLAB quite a bit, and that was, I think, an array-based language. There's also ones for science and business. Third-generation languages have a very high level of abstraction. They also introduced specialized syntax and offered great enhancements in logical structure. Compilers are an important part for any high-level programming language. They were introduced in 1952, and they have allowed for high-level languages to become machine or hardware independent. They accomplish this by compiling code into the respective companion assembly languages for different CPUs. Besides compiling code, they also check code for errors and discontinuities. They also update internal data tables, and they generate either CPU instructions or library calls. Fourth generation languages are an extension of third generation languages. They provide a higher level of abstraction. They are more programmer friendly. Typically, they're more powerful and versatile than third generation languages. They also include support for database management, report generation, mathematic optimization, graphical user interface development, and web development. Fourth generation languages are I'm most familiar with them due to SQL and LabVIEW. They're domain specific languages, and as I said, I'm most familiar with them for their use in database management. Fifth generation languages are a non-procedural language, which means that they describe a processing requirement without specifying a procedure for satisfying that requirement. The compiler or interpreter determines the most suitable procedure for retrieving the data or executing whatever CPU instructions are needed. Fifth generation languages are used to mimic human intelligence and are used mostly in AI. They contain rules similar to that of human problem solving, and then can be used to solve abstract problems. The first fifth generation languages were Lisp and Prolog. Most fifth generation languages are proprietary and are used to build expert system applications, mostly in medical diagnosis and credit application scoring. A fifth generation language usually accepts a starting state as an input, and then it applies rules iteratively to achieve a solution. This can be used for AI trying to solve abstract problems. An example of the book in our book is given as a AI trying to solve a problem of moving a farmer, a fox, a chicken, and corn across a river on a boat. And a fifth generation program could use these abstract rules to solve the problem, whereas a previous generation of language would probably need to use a if or an if-else statement to solve the same problem. Fifth generation languages are versatile. They were introduced in the 1960s, but they didn't find a use until the 1980s. The last type of programming language is known as object-oriented programming languages, or OOPs. OOPs are different from any previous generation of programming languages in that data and the program, also known as methods, are two parts of an integrated whole called an object. This wasn't the case with previous programming languages. There was a distinction between the program and the data used by the program. OOPs basically got rid of that distinction, and everything is known as an object. The first commercial OOP language was Java. Later OOPs include C, C++, and other languages such as Visual Basic have extended upon the OOP concept. OOPs are used primarily in OSs and interactive user interfaces. Most web browsers and OSs are written in OOP. OOPs better address program reuse and long-term software maintenance. Good software design combined with OOP language promote reusability and portability of source code. And as you noticed, OOPs are not referred to as sixth generation programming languages because the concept of language generation is no longer relevant. OOP languages aren't a clear successor to anything, including fifth generation languages, because they're neither non-procedural nor used exclusively for developing expert system applications. Some OOPs are actually extensions of third generation languages, such as Java, and are actually more closely related to fourth generation languages than fifth generation languages. Well, thank you for listening to my presentation. I had a great time researching the development of programming languages and learning some of their applications. Thank you.